Welcome, students. This is Unit 1, the Alphabet and Grammar of Geometry, Preview Video 1.1, Algebra Review using radicals. The next step, we're going to take a brief moment to do some deep breathing exercises. And the reason why is we're increasing your oxygen to your brain, increasing your focus, lowering your stress levels. Follow along with me. Please don't skip this step. Ready? We're going to inhale slowly through your nose for a count of 3. Ready? Inhale. Hold your breath for a count of 3. Slowly exhale, count of 5. Do this one more time. Ready? Inhale. Hold. Slowly exhale, count of 5. Now just close your eyes for about 10 seconds and just sit there. Take another deep breath. Don't ever skip that step. It's good for your brain. It's good for your thinking. And this class is all about thinking clearly and concisely. Okay, as you work through this video, you should have a parent, a teacher, a guardian in sight, someone that is witnessing this, and you need to record the date, time, and location, as well as you get a parent or guardian sign off. So the first couple lessons, we're going to review some of our basic algebra skills. So lesson 1.1, algebra review, radicals. There's your key terms. Just kind of read them to yourself and do a little quick check. Read them out loud. For this geometry class, there are 3 essential previous math skills you need to master to be successful. The first is being able to add, subtract, multiply, divide, and simplify radicals, also known as square roots. You need to be comfortable with computational math. That means adding, subtracting, multiplying, dividing, which you're going to be doing by hand, not using a calculator most of the time, and working with fractions. And you need to be comfortable solving for variables in basic forms. We're going to be focusing just on this first one for this lesson. All right, ready. Let's just define what is a square. A square of a number is related to a physical square. Good news in geometry. So the area of a square is simply length times width. So in this case, length times width would be 3 times 3, of course, which would be 9 centimeters squared. So 3 times 3 equals 3 squared, which is 9. So that square means to times by itself twice. It does not mean times by 2. To find the area here, area equals length times width. So it'd be 5 times 5, which is 5 squared. That's not 10, that's 5 times 5, which of course is 25. Units, you always need to account for units when you're dealing with lengths that have units. So this would be area would be 9 centimeters squared. The area here would be 25 feet squared. If there are units in your original problem, there's units in your answer. Now, you're going to be given a square. You're going to work backwards. Or the fancy name there would be inverse. What is the inverse operation of squaring? And the inverse operation is square rooting. So I'm going to count to 20. Your job is to, if the area of this square is 36 centimeters squared, what would the side lengths be? And of course, in a square, the side lengths are all congruent. Those little tick marks mean they are of equal length. Same over here. If the area of this square is 16 centimeters squared, all four sides are equal. What would those side lengths be? I'm going to count to 20, and you are going to fill those out as fast as you can. Ready? No calculator. All right, so working backwards here would be if the area is 36, our side lengths would have to be 6 and 6 in a square. If the area here is 16 centimeters squared, oops, that should say feet squared, then this is going to be 4 and 4 because 6 squared is 36. And the inverse operation, the square root of 36 is 6. So that's called the inverse operation. This is all an algebra review, so this should not be completely new to you. So I'm going to do the first row only, and then you are going to zoom through and do as many of these as you can from memory. These must be memorized. So the first row, 2 squared is going to be basically 2 times 2, which is 4. And then the square root of 4 would be 2. Coming over here, 9 squared is 9 times 9, which is 81. And then the square root of 81 is going to be 9. Square rooting is the inverse operation of squaring. Ready? I'm going to count to 30 seconds. You fill out this entire page as fast as you can from memory. Go. You can do it. Keep at it. Go fast, 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 fast. Fill out as many as you can from memory. Okay, check your work. I'm just going to write in the answers here. And again, these must be memorized. 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 times 7 is 49, 8 times 8 is 64. We already did 81 here. This is 100, 121, 144, 13 squared is 169, 14 squared is 196. And 15 times 15 is 225. The way I remember this one, if I remember 169 for 14, you just switch it the other direction. And then working backwards, the square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, and down you go. Again, both the squares and square roots must be memorized, at least 2 through 15. Okay, so these numbers, when you have a single number times by itself, we call that a perfect square. Perfect square. So you can see when you square root a perfect square, it just undoes it and goes back to the original number. That's called simplification. So the question is, How do you simplify a square root if it's not a perfect square? If it's not one of the green? And that's where we get square root simplification. I'm going to do it two ways here, and I relate it to going on a date. So first you start by what's called prime factoring. And I'm going to do it two different ways. And I'm going to use what's called the tree method, and then I'm going to use what's called upside down division. Both get you the same answer. I just want you to see both. You might be familiar with one versus the other. So I'm going to start, and I generally, if it's even, I start with 2. If it's divisible by 3 or 5, 7, or 13. So that's what you're looking for is factors 2, 3, 5, 7, 13. Generally, one of those 5 will work for almost everything. Ready? Let's factor 108. I'm going to do a 2. Just going to keep going on down here. And you keep going until until you have nothing but prime numbers. Upside down division looks like this. If I have 108, I go like this, 2 and 54, 2 and 27, 3 and 9, 3 and 3. Here's the storyline. That's why I have a couple here. You're only looking at what is considered the leaves. These would be the leaves. These would be the branches. So you're not looking at the branches. You're only looking at the leaves. In the upside down division, you're only looking at the outer numbers. And the storyline is this. If you have a date, which means a double of the same number, and the reason why we're using a double, because a square root, technically there's a 2 there. So for every 2, you can pull out one number. So it looks like this. For every 2, I can pull out one number. And then whoever doesn't have a date stays home, orders Uber Eats. So that's going to be a 3 there. These outers multiply. So the final simplification of root 108 is going to be 6 root 3. Same thing here. There's a 2, every double. There's a 3. No date, stays home. Bad social advice, but works for a math example. 6 root 3. This one looks a little different because there's something already on the outside. That's called a coefficient, by the way. So this is called a coefficient. I'll show you what to do with that in just a moment. But you start by factoring the same way. So if it's even, I'm going to use 2. Copy down the backwards division so you can see both. Remember, the storyline is if you have a date, which means a double. So there's a date. There's a date. You get to go out, but you go out as a singular entity. All right, so we have a 3 and a 5, the coefficient outside. So 3 times 5, and then the 2 and the 3 stay under the radical, stays home as it were. And then everybody multiplies. This is going to be 15 root 6. Ready. You just learned something. Many of you maybe didn't understand this last year, and now you do. Write yourself a quick note, pause the video. What do you want to remember? Welcome back. Next page. Now, super important, students, please, I beg you, remember effort creates understanding. Effort creates understanding, not copying. Copying does not create understanding. So when you see this little symbol, when I say you try, that means you get your pencil out, you do this page, you pause the video, then you restart with a red pen in your hand. Do this page by yourself. Pause the video. All right, you should have a red pen now. You should have worked in pencil. Now you get out a red pen. As I explain, if you want to put this on double time, you may. If you think you understand it, I'm just going to very quickly go through. All right, so here we have 63. You should have known that was 7 times 9, 3 and 3. The 3 comes out. That's going to be 6 root 7. Over here, I'm going to do this upside down division. 2 and 120, 2 and 60, 2 and 30, 2 and 15, 3 and 5, and 1, 2 comes out. Another 2 comes out. The 3 and the 5 stay home, as it were. Final answer for root 240 is going to be 4 root 15. Now, if you get these right, I expect a star, smiley, some sort of acknowledgement. I'm so amazing. If you got this wrong or incorrect, totally fine. But I want you to redo the corrections and then write yourself a note. What do you want to remember? That's called reflection, cements retention. It's part of our chance. Cement reflection, cements retention. Now that you can simplify a radical, we're going to learn how to add, subtract, multiply, and divide. Again, all of this should be a review from Algebra 1. Let's take this algebraic expression with z's, y's, and x's, and we are going to basically collect like terms. So let's see what we can do. The z's collect. Notice I like you to underline, double underline, and triple underline as you collect. That helps your eyeballs put the numbers together. I'm going to collect the x's first because normally in algebra we do things alphabetically. So I essentially have 3 minus 2 here. So that's going to be 1x. And the y's, 8 minus 5. That's going to be positive 3y. And then here I have negative 7 plus basically 1z. So negative 7, I'm down 7 below ground, and I go up 1, I'm still negative, so it's going to be minus 6z. And we are done. What you need to understand is radicals follow the same rules as variables. So exactly how I collected those variables is how I'm going to do the radicals. So the first thing I check is to see if I can pull apart any dates in the radicals, if I can simplify them. Remember, simplifying means if there is a factor that's a double, you can pull it out. So I have a 2, a 5, a 3, a 5, a 3, and a 2. And what I mean by factor is this. This is 1 and 2, 1 and 5, 1 and 3, 1 and 5, 1 and 3, 1 and 2. Now, if you look at those factors, all of them are prime. There's no doubles there. So I can't simplify. So once I've determined I can't simplify, then you simply add and subtract alike kinds, just like you do the variables. So I'm going to collect my root 2's, underline. I'm going to double underline my root 5's, triple underline my root 3's. All right. There's no alphabetical order here, so I'm just going to work left to right. So I'm going to do my root 2's first. So I basically have 7 minus, there's a 1 there. Negative 7 plus 1 is going to be negative 6 root 2. And then I do my root 5's. That's 3 minus 2. That's going to be plus 1 root 5. Then I do 8 minus 5. That's going to be plus 3 root 3. I could have rearranged that order any way I chose to. I could have easily done root 5 plus 3 root 3 minus 6 root 2. That's fine too. Okay, but radicals follow the same rules as variables. Notice here the variables did not change. The variables didn't change, nor did the radicals when you add and subtract. Okay, but the main rule is you have to simplify first. So let's do this problem together, and then the problem down below you're going to do on your own. So we're going to start by simplifying our numbers, if possible. This one I'm going to do upside down division just so you can see both. All right, now we're going to go through the process and simplify where we can. So right here, I have a pair of 2's, but only 1 comes out. So it's going to be negative 2 root 5. Pair of 3's, only 1 comes out. Multiply 3 times 3, that's going to be minus 9 root 2. No dates, stays exactly as it is, minus 3 root 5. This one, I have a pair of 3's. They come out as a single 3. Multiply plus 6 root 5. Okay, we've simplified. Now we collect like terms. Ready? Underline your root 5's. Double underline your root 2. We're going to collect. Negative 2 minus 3. So if this is 0, negative 2 means I go down 2, minus 3 more, 1, 2, 3, and I'm going to be at negative 5. So that's going to be negative 5. Then I add 6. So I go 6 back up this way, and I end up at positive 1. So that's going to be positive 1 root 5. So I'm done with my root 5's minus 9 root 2. Once you have simplified your radicals and all your radicals have been collected and you do not have alike radicals, you stop. This would be exactly like saying 1x minus 9y. You can't go any farther. You are done. Ready? Here's another you try. You try means you're going to pause the video, do it yourself, and then restart. Ready? Pause the video. You should have a red pen now. You're going to check your work. Your work may not be exactly the same as mine, but look at the final answer here. When you simplify, you should have gotten negative 2 root 5 minus 9 root 2 plus 3 root 2 plus 4 root 5. Then you collect like terms. And then here we have negative 2 plus 4. That gives us the 2. And then negative 9 plus 3 gives you negative 6. And you could write it like this, or you could have written it like this: negative 6 root 2 plus 2 root 5. Either of those would have been acceptable. So, star smiley if you got it right. Woohoo! If you didn't get it right, totally fine. Write yourself a note. What do you want to remember? I'll be looking for your notations here. What do you want to remember? You learn by reflecting and then correcting. All right, multiply and divide. Multiply and divide. Outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. Do it again. Outies, innies, simplify. Now, if you're a little shocked right now, get used to it. You're going to be doing a lot of singing, chanting, and rhythm in this class. It helps your brain understand. Outies. I'll explain what all this means in just a moment. Outies. This is obviously a slang term, not a technical term. Innies. And simplify. Outies, innies, simplify. Outies, innies, simplify. This is for multiplication. Let me explain. It's really not complicated at all. Super easy. Outies. You take the outer coefficients and you multiply. So it's going to be 3 times 7. Innies. They are going to multiply as well, but under the radical sign. And notice I'm not actually multiplying there. There's a reason why. Okay, outies, innies. Now simplify. So under the radical sign, I have a 3 and a 6, and that's a 1 and a 3, 2 and a 3. And I simplify by taking out the doubles, taking out the date. So I'm going to circle, circle. That means only 1 3 comes out. Now I do at the outside, that's 9 times 7. And if you know your nines fingers, 9 times 7 is 63. 9 times 7 is 63. If you have no idea what I'm doing right now and you don't know your nines fingers, ask me in class. It will help you immensely. Actually, since this is reverse, it should be like this, 63. 9 times 7, 63. So we have 63 and then root 2, and you're done. Ta-da! Outies, innies, simplify. This one, pause the video, do it yourself. Pause. All right, get your red pen. Get your red pen. You multiply the outies. You should have gotten 70. Multiply the innies. And it's 5 times 15, but you don't multiply, you factor. You have a pair of fives. The 5 comes out. 5 times 7 is 35, times 2 is 70. And then lonely here has no state, stays home. So your final answer here should have been 70 root 3. Woo woo! If you got that right, star smiley. Okay, and if you didn't get it right, that's totally fine. Correct your work, write yourself a note. What do you want to remember? That was multiplying. Multiplying radicals. Last page for dividing radicals. Outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. Ready? Okay, now we're dividing radicals. So here's a dividing line. Follow a very similar process. First, we're going to, instead of multiplying the outies, multiplying the innies, we are dividing them. So you reduce and divide if at all possible. So there's your outies. 24 divided by 4 is 6, and the 6 goes on top because it's heavier on top there. Then here, the 21 and the 15, nothing directly, 15 doesn't go directly into 21, but they're both divisible by 3. So 15 divided by 3 is 5. And 21 divided by 3 is 7, still under the radical sign. Outies, innies. Now, simplifying radicals. The main event is that you have to get rid of that square root sign out of the denominator. And to do that, we're going to multiply by its identity, which is we're going to multiply top and bottom by root 7. I'll explain why in just a second. Just be patient. To get rid of that radical, you multiply by the exact same radical in the denominator. Okay, ready? We have 6, 5 times 7. We can't pull those apart. We leave it. Technically, root 7 times root 7 is root 49. But way earlier, you already memorized root 49 is perfect. So it simply becomes 6 root 35 over 7. And you're done. Check your outies. Can't do anything with it. No more innies. No more radical in the basement. There you are done. Ready? Again, a you try. Outies, innies, simplify. Pause the video. All right, let's see how you did. First, we reduce the outies. 6 goes into 42 7 times, and it's heavier in the denominator, so it's in the basement. Both 32 and 12 are both divisible by 4, so I reduce that. 32 divided by 4 is 8. 12 divided by 4 is 3. I want to get rid of that radical in the denominator, so I multiply top and bottom by root 3. And this is what you end up with, or you should. I have 8 and 3, and then I have 7 times 3. Warning, be very careful here. That 3 up here is under the radical. That 3 down there is outside of the radical. You cannot do that. What I just did was wrong. If you did that, you need to correct it as part of your red pen corrections. So those have nothing to cancel with, 21. But wait, there's more. 8 breaks down. 2 times 2 times 2 times 3. There is something you can simplify. You can take out a pair of 2's. Final variation here should be 2 root 6 over 21. Check. Can't reduce the outies, nothing to reduce on the innies, and you are done. Outies, innies, simplify. Again, if you got that correct, give yourself a big star smiley. Not correct, totally fine, but write yourself a note. What do you want to remember? Which portion of this was new to you? I'm going to pick up the pace here. I know this is a little bit longer. Normally, the videos will not be 45 minutes long. Generally, they'll average about 30 minutes, but this is a super important topic. So I'm going to pick up the pace here just a little bit. I'm going to show you a shortcut. Everybody likes a shortcut. Ready? So outies, innies, simplify. We're multiplying radicals. We're just multiplying here. Root 2 times root 2 technically is the square root of 2 times 2, which makes it square root of 4, right? But root 4 is perfect. Square root of 4 is just straight up 2. Look at what happened here. Root 2 times root 2 is just 2. Let's try another one. Root 7 times root 7 technically is square root of 7 times 7, so it's root 49, but root 49 is perfect. That's why you need to know your perfect squares. It's just 7. Root 7 times root 7 is just 7. Let's come down here. Root 5 squared looks like this. When you have an exponent, you're going to expand it. It looks like this, root 5 times root 5. Now take a look up here. Any radical times itself is just the number on the inside. So we're going to skip this in-between step and go straight. Root 5 times root 5 is just 5. The square root of 17 is root 17 times root 17. Do not bother multiplying 17 times 17. It's a waste of time. You know any radical times itself is just the number on the inside. So root 17 squared is just 17. That's it. It's a little shortcut. Ooh, what's going on here? We have 3 root 2 times root 2. You just learned any radical times itself is just the number on the inside. So root 2 times root 2 is 2. 3 times 2 is 6. So 3 root 2 times root 2 is 6. Now we're going to work backwards. 6 root 5 times what number is 30? Now some of you are thinking, I know 6 times 5 is 30, but there's a radical there. We need to get rid of the radical. Any radical times itself is just the number on the inside. So root 5 times root 5 is 5. 6 times 5 is 30. So the correct answer for this blank is root 5. Ah! Oh no! 2 doesn't go evenly into 7? What's up with that? Remember the simple rule. Any radical times itself is just the number on the inside. So if I want to get rid of root 2, if I want to get rid of that root 2 over here, I know I at least need a root 2. Okay, we got that far. If I have a 7 over here, that means over here there's got to be a 7 there somewhere. Got that far. Let's see what we have so far. Root 2 times root 2 is 2. 7 times 2 gives us 14. If I want to get 14 back down to 7, what do? I divide by 2. That's it. So the correct answer for something times root 2 is 7 is this entire entity, 7 root 2 over 2. That is a single number. I know it doesn't look like a single number. It's called a term. It's a single term. Ready? All right, friends, take the training wheels off. Zoom through this page as fast as you can. Pause the video. Welcome back. Ready? I'm just going to give the answers here, and then you got to go back and figure out why it's right or wrong. Ready? This one's 5. This is 6, 15. This is just going to be 3, 21. That's going to be 30. This is root 3. This is root 3, 4 over 3. 4 root 3 over 3. Oof. And if you got all of that, that's amazing. If you didn't get all of that, that's okay. You're learning something. Go ahead and write yourself a note. What do you want to remember? If you got it right, big star smiley. Or if you got one of these wrong, write yourself a little note. What do you want to remember? Ready? Summarize in your own words what are three things that you really want to remember. Summarize the main concepts from today's lesson, especially anything that felt new to you.